Good day guys, welcome to Calcumind, and today we're looking at binomial distribution. So binomial distribution is a kind of distribution that measures the number of success in a given number of trials. So let's say, for example, you're given a loop and you're asked to throw a ball into that loop. The number of times you succeed in throwing that ball into that loop is what binomial distribution aims to measure. So when do you know a binomial distribution question? It has a fixed number of trials. So if you're given 10 times and you're asked to throw a ball into that loop, the number of times that the ball enters, that is what binomial distribution aims to measure. And secondly, each trial is independent. So for the first trial, you throw the ball into the loop. It should not affect the second trial. And for the third trial, the occurrence of the second trial should not affect the third trial. So that is when you know it's a binomial distribution question. And a binomial distribution question has only two outcomes. The outcome of a binomial distribution should have only two outcomes. It's either the probability of you succeeding or the probability of you not succeeding. So it's either you win or you lose. So a binomial distribution has mean, also has variance, which are being represented with the formula. The formula for binomial distribution for the mean is equal to NP, which is the number of trials, where N and P is the probability of you succeeding. So now we have gotten the value of our mean. So also, a binomial distribution has the formula for variance. So this is the formula for variance. We are going to be walking through a sample problem whereby it states that a discrete random variable has mean 6 and variance 2. They say we should find the probability that P falls between a number x falls between 4 and 8. If you think this true, what numbers falls between the number is greater than 4 but less than 8? If we look at this carefully, which number is greater than 4? We have 5, 6, and 7. So this is the numbers that are greater than 4 but less than 8. The binomial distribution formula is being represented with this, whereby P of x is equal to n combination x, P of x, 1 minus P, n minus x. So as earlier said from this problem, we can work out that n is the number of trial. X, for example, this equation now that we can see, x is the number that we are looking for from here. P is the probability of you succeeding. N is also the number of trial. So now we are going to be using this formula to work out this problem. They said the mean is 6 and the variance is this. So we'll use this our formulas to work out this problem. We can see that the mean, we will be tasked to find the probability of you succeeding. It was not given in the equation. So let's work out the probability of you succeeding. They say mean is equal to NP. So we'll say 6 is equal to NP. And the variance also is equal to NP 1 minus P. So they say the variance from the equation, from the problem, we can see that 2 is equal to NP 1 minus P. So from this mean, we can see that 6, we can make N or P the subject of the formula and plug it in here to find one of the variables. So let's do that. 6 divided by P is equal to N. We'll then be substituting it into the variance. So this 2 is equal to 6 over P, P 1 minus P. You can see that this P cancels out the P. So this 2 is equal to 6. P cancels out P, 1 minus P. And you should recall that P is the probability of you succeeding. So 6 divided by 2. We want to make P the subject of the formula. So this is 6. So this is 1 over 3 is equal to 1 minus p. So we want to make p the subject of the formula. What we'll do simply is simply cross multiply. So this 3 multiplied by 1, that is 3. 3 multiplied by minus p is minus 3p is equal to 1. This 1 multiplies by the invisible 1 over here. So if we make p the subject of the formula, this 3 goes over here, is minus p. Okay, let's write it out here. This minus 3p is equal to 1 minus 3. So this minus 3p is equal to 1, is equal to minus 2. So making p the subject of formula, we are going to be dividing through by minus 3. So this minus 3, minus 3. So p is equal to 2 over 3. From this equation now, we can see that the probability of us succeeding is 2 over 3, and we are going to be plugging it into this equation. This binomial distribution equation, 2 over 3, we are going to be plugging it in here in order to solve for the probability that x is between 4 and 8. Okay, now that we have gotten to this point, we are going to be using the binomial distribution formula to work out the value when p, the probability of us succeeding at 5, and the probability of us succeeding at 6, and also the probability of us succeeding at 7. So let's do that. It's going to be p x is greater than 4 is greater than x, and x is less than 8 is equal to the probability that x is equal to 5, as I told you earlier, plus x is equal to 6 plus x is equal to 7. So we are basically summing the probability that we are going to succeed at 5, summing the probability we are going to succeed at 6, and summing the probability that we are going to succeed at 7. So now, we'll be working out the probability that we are going to succeed at 5 using this formula. So p x is equal to 5 is equal to, earlier I told you that n is equal to what? The number of trials. And the number of trials, n, is equal to, from the equation we solved for it. Okay, we haven't solved for it. We'll just basically plug in 2 over 3 into this equation. So let's work that out. To solve for n, we'll do 6 divided by 2 over 3. So this 6 over p is equal to n, which is equal to 6 divided by 2 over 3. So if we work that out, it's going to be 6 times 3 divided by 2, which is equal to 6 times 3 is 18. 18 divided by 2 is 9. So n is equal to 9. So now, from this equation, we know that our n is equal to 9, and our p is equal to 2 over 3. So we'll be working this out. 9 combination, our x is 5. As I told you earlier, x, this is the value of x. We are going to be putting it here. P is what? From here, we can see that p is 2 over 3. So this is 2 over 3 raised to power x, which is 5. 1 minus 2 over 3. The probability of us succeeding. This is just like the complement. So now, n is what? 9 minus x. Our x is 5. So we are going to be repeating this same procedure for x equals to 5, for x equals to 6, and x equals to 7. And then summing them up to get the probability that x value is less than 4, but greater than, is greater than 4, but less than 8. So let's work this out. P of x is equal to 5 is equal to, using the combination formula, combination is simply nc of r is equal to n factorial divided by n minus r factorial. So n factorial, n minus r factorial is what we are going to be working with. So this is 9 factorial divided by 9 minus 5 factorial. 5 factorial minus 4 factorial. 5 factorial. 2 over 3 raised to power 5. 1 over 3 raised to power 4. So now let's simplify this in order to get an answer. So this is 9 factorial, 9 times 8 times 7 times 6 times 5. You'll be asking yourself, why are we stopping at 5? We are simply stopping at 5, so this 5 can cancel out this 5. Factorial go all the way from 9 times 8 times 7 to 6, 5, 4, 3, 2, 1. So you're just basically multiplying all the numbers that are behind the initial number, which is 9. So that is the way factorial works. So this 2 over 3 multiplied by 5, 1 over 81. So what do you get as the answer for Px equals to 5? 0.2048. Okay, we'll be doing the same thing for x equals to 6. So now, we'll be doing the same thing. So 9, n is equals to 9. So this is 9 combination 6 multiplied by 2 over 3 raised to power x, and our x is 6. Then this is 1 minus 2 over 3. Oh God. This is n 9 minus 6. So the same thing we did for 5, that's what we'll be replicating here. 6. 1 minus 2 over 3, we'll be getting 1 over 3 raised to power 3. So this, when we work it out, is going to be 9 times 8 times 7 times 6 factorial divided by 6 factorial, 3 times 2 times 1. We want this 6 factorial to cancel this out. That is the idea for further expanding this. So this 2 over 3 6 1 over 27. So if you punch this in your calculator, what do you get? 0.2732. So now we'll be doing the same thing for x is equals to 7. So this n is 9 combination 7 multiplied by 1 over 3 raised to power x, which is 7, multiplied by also 1 minus 2 n minus x. So this is 9 minus 7, we're having 2. So let's work this out. It's going to be 9 factorial, 9 minus 7 factorial, 7 factorial, 2 over 3. So this is 1 over 3 square. This will be 9 times 8 times 7 factorial, all divided by 2 times 1 multiplied by 7 factorial. It's the same thing that we did for 5 and 6. We are doing it for 7, so we can sum them up together. So this 2 over 3, 7, 1 over 9. If you punch that into your calculator, what do you get? 0. What? 2, 3, 4. Let's stop there. So now the probability that 4 greater than x less than 8 is equal to what? Call all the numbers there. 0.20. Plus 0.27 plus 0.23. So once you sum them up, what do you get? 0.71. So now the probability that the number x is greater than 4 but less than 8 is equal to 0.71. So that is the solution for this binomial distribution question. Make sure to like, share, and comment. And any question you have, leave it in the comment section. Thank you.